Hey friends, I wanted to look at a few of these problems with you so we can practice adding mixed numbers. This is a good opportunity for us to practice the skill of finding the least common denominator for two numbers. I think I'm getting ready to let you work on the rest of them on your own. This one looks interesting. This is a different kind of question. Which is a good comparison? Hold on, let's look at it bigger. It'll make it easier. Sorry, I should say the least common multiple for two numbers, my bad. Okay, so we're going to add 7 2/3 plus 8 5/6. Now the whole number amounts for our whole numbers we can just leave alone and add those separately. So 7 plus 8 equals 15. Now we just need to take our 2/3 and combine that with 5/6. If we look at this in a visual model, let's begin by considering what 2/3 looks like visually. If I eat 2/3 of a pan of brownies, that's what that's going to look like. I can take this same model and divide each third in half. Now I have 6. If I shade in one more, that gives me my 5/6 for my second addend. Let me do the same thing over here. That converts my 2/3 to 4/6. 1, 2, 3, 4, 5, 6 pieces, and 4 of them are shaded. So 4/6 plus 5/6 give me 9/6. And I can convert that to a mixed number. So 9/6 is the same as 6/6 plus 3/6. 6/6 is 1 whole. 3/6 is the same as 1/2. So that's what it would look like in simplest form. Then I just need to add that to the 15 I started with. That gives me 16.5. Let me just show you what that looks like on our visual model. If I take this 6 and this 6 and I move it over here, now I have 6/6 or 1 whole. So this matches with this, my 6/6. Okay, now these are gone because I moved them over. That leaves me with 1, 2, 3/6 or 1/2. Just see. Let's work on number 7. So we're going to skip over a few of the practice problems and focus on number 7. Write two mixed numbers that have a sum of 3. Now the way I'm going to suggest you approach this is by, again, working with a visual model. Start with 3 wholes and then think about how you can cut these up to equal 3. Since we have to have 2 mixed numbers, let's go ahead and assume that the 3 is going to be cut into 1 whole with a fraction plus 1 whole with another fraction for a total of 3. Then we can take our last whole down here and we can cut that up into as many pieces as we want. You could cut it into fourths and do 2/4 plus 2/4 equals 1 whole. You could cut it into 5 equal pieces and do 1/5 plus 4/5. You could cut it into sevenths and do 3/7 plus 4/7. That part's really up to you. I'm going to do sixths. And I'll do 4/6 plus 2/6. So 1 4/6 plus 1 2/6 equals a total of 3. Now we want to start getting into the habit of writing things in simplest form. This 4/6 in simplest form would be 2/3, and this 2/6 in simplest form would be 1/3. Problems on your own, let me know if you have any questions. Remember, if all of this fraction stuff feels like it's leaving you in the dust, you need to start coming to study hall so that I can help you. Okay, now we're going to take a look at these word problems. It's really important to focus first on this chart, which tells us some data about how much the average woman's brain weighs in kilograms, and then it tells us how much that same brain, that same average brain, would weigh in pounds. So kilograms and pounds are our 2 units of measurement. Question 8 asks us to figure this out. What is the total measure of an average man's brain and heart in kilograms? So we know we're looking over here on this part of our chart. We're going to do 1 2/5 plus 3/10. We have 2 unlike fractions here. So our 1 whole number is just going to move over. 2/5 needs to be converted to 4/10. When we're adding fractions, we're just going to add the numerators. 4 plus 3 is 7/10. So did I do that right? Average man. Oh yeah, I skipped down from number 8. Okay. So 1 7/10, that's already in simplest form, so we can just leave that alone. Number 9. What is the total weight of an average woman's brain and heart in pounds? So we have to switch over to pounds now. Brain and heart. So 2 4/5 plus 7/10. Our whole number can just move over. Let's talk a little bit about this common denominator in case you need a refresher. We're going to find the least common multiple for 5 and 10. So that means we're going to skip count by 5s. And I can stop after just a few multiples because I can already see the smallest number that's on both of my lists is 10. So that's why I selected 10 as my common denominator for this one. I'm going to convert 4/5 and figure out how many tenths that's equivalent to. Whoops. And let's do it with a visual model just for extra practice. So here's my fifths. 1, 2, 3. There's 5 equal pieces. I'm going to shade in 4 of them. And remember, this model represents how much the average woman's brain weighs, which is kind of a weird thing to think about, but okay. Here we go. Okay. So there's my 4/5. Now, when I take this 4/5, if I cut each of those fifths in half, now I have 10 equal pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal pieces, and 8 of them are shaded. So 2 4/5. Okay, I already dealt with my 2, so I'm going to leave that alone. But 4/5 is equivalent to 8/10. Add that up with my 7/10. That gives me 15/10. So, whoops, I don't want to do that yet. 15/10 is the same as 10/10 plus 5/10, or 1 5/10. In simplest form, that means 1 1/2. So I just have to take this and combine it with my 2. So 2 plus 1, oops, so 3 1/2. 3 1/2 pounds. Oh, and let me not forget my units here. Really important with measurement problems to include your units. All right, let's look at number 10. What is the sum of the measures of an average man's brain? I can't get over how weird this is. Okay, what is the sum of the measures? Sum means adding. Of the average man's brain and the average woman's brain in kilograms. So we're going to calculate, I'm kind of running out of space here, but average woman's brain, 1 3/10, plus average man's brain, 1 2/5. So if you combined those two brains, you would be doing 1 plus 1 gives you 2. 3/10 plus 2/5. 3/10 you can leave alone. 2/5, how many tenths is that going to be? 2/5 is the same as how many tenths? Let's look at it visually. 2/5 looks like this. If I cut each fifth in half, now I have 4/10. 1, 2, 3, 4 out of 10 equal pieces. That gives me 7/10, for a total of 2 7/10 kilograms. All right. Work on the rest of these. Okay. Which is a good comparison of the estimated sum, whoops, highlighter. Which is a good comparison of the estimated sum and the actual sum of 7 7/8 plus 2 11/12. So when you come up with an estimate, you might round. You could round 7 7/8 to 8 and 2 11/12 to 3, and that would give you 11. And then when you add the exact answer, let me do that in a different color. Let's see, I rounded up exact answer. When you round up, that means that these numbers are bigger than what the exact answer will be. So the exact answer will be a bit smaller. You need to look at these answer choices, and it's written in kind of like a code. Is your estimated answer less than the actual answer? Or is your actual answer greater than the estimated answer? Aren't those two the same? I'll have to look at that. Or is the actual answer exactly equal to the estimated answer? Or is your estimated answer bigger than your actual answer? Now, I'm going to go ahead and say that these two things mean the same thing. Estimated is less than actual. Actual is greater than estimate. So interesting. I'll be curious to see what you guys choose. A, B, C, or D.